Today we are going to discuss about the nature of roots of a quadratic equation. So what is the nature of the roots? The nature of the roots is determined by the form d equals to b square minus 4ac. So this is called discriminant. This d is called discriminant here. So d means discriminant and d equals to b square minus 4ac. So see that the three cases will be there. So in three cases, firstly, if d is greater than or greater than equals to 0. D is greater than or greater than equals to 0. That means this is given real and distinct roots. Real and distinct roots. Case 2, if d equals to 0. If d equals to 0, that means real and equal roots. Real and equal roots. And number 3, if d is less than 0. If d less than 0, that means no real roots. Okay, no real roots. So no real roots means this is a imaginary root. Imaginary root. This imaginary root will be calculated in class 11. So just for information I am telling this is imaginary roots. Now three conditions is very important for finding the nature of the roots. So if d greater than equals to 0, that means this is real and distinct. Okay, for d equals to 0, that means this is real and equal. And for d less than 0, that means no real roots. Okay, no real roots. Now we are going to discuss the problems for this type of things. Go to the exercise. Now exercise 5D. So in exercise 5D, see that 1 and 2, this is 2x square minus 3x plus 5 equals to 0. Right, comparing with ax square plus bx plus c equals to 0, we get a equals to 2, b equals to minus 3, c equals to 5. So a equals to 2, b equals to minus 3, c equals to 5. So now we can write d equals to b square minus 4ac. So b equals to minus 3, that means minus 3 squared, that means 9, and 4ac, 4 into 2 into 5. So that means 9 minus 40, that means minus 31, that means less than 0. So d less than 0, that means no real root. So d less than 0. That means no real roots. So this is the nature of the roots. Okay. Now note it down, all of you. Now in 1a3, see that 16x square minus 40x plus 25 equals to 0. So comparing with ax square plus bx plus c equals to 0, we get a equals to 16, b equals to minus 40, c equals to 25. Therefore, d equals to b square minus 4 equals to minus 40 square minus 4 into 16 into 25. So that means 1600 minus 1600. That means 0. So d equals to 0. That means two equal and real roots. So d equals to 0. That is two real and equal roots. So this is the nature of the roots of this equation. Okay. Now next one. In 283, given 2 minus 2x square plus x plus 1 equals to 0. We have to write the same words comparing with ax square plus bx plus c equals to 0. Then we get a equals to minus 2, b equals to 1, c equals to 1. So d equals to b square minus 4ac equals to 1 square minus 4 into minus 2 into 1. So that means 1 plus 8, that means 9. So 9 is greater than 0. So greater than 0 means two real and distinct roots. So therefore d greater than 0, that is two real and distinct roots. Okay. Note it down a little. Now next one. In 4, see that without solving the following quadratic equation, find the value of p for which the given equation have real and equal roots. So conditions is given, that is equal and real roots. Okay. So see that the equations given x square plus p minus 3 into x plus p equals to 0. So comparing with ax square plus bx plus c equals to 0, we get a equals to 1, b equals to p minus 3, c equals to p. Okay. Now for real and equal roots, b square minus 4ac equals to 0. So for real and equal roots, b square minus 4ac equals to 0. Now you put the value of this into this form. That means p minus 3 whole square minus 4 into 1 into p equals to 0. So now this implies, so p minus 3 whole square, that means p square minus 6p plus 9 minus 4p equals to 0. Okay, that implies p square minus 10p plus 9 equals to 0. That implies p square minus 9p minus p plus 9 equals to 0. That means p minus 9 into p minus 1 equals to 0. So either p minus 9 equals to 0 implies p equals to 9, or p minus 1 equals to 0, that implies p equals to 1. So p equals to 1 and 9. So the value of p is 1 and 9 here. Okay. Note it down all of it. Now in 6.2, see that find the values of n for which the following quadratic equation has real and equal roots. Same problem is this. So real and equal roots given, that means b square minus 4ac equals to 0. Okay. So now 6.2. So the equation is given. See that x square plus 2 into m minus 1 into x plus m plus 5 equals to 0. So that means comparing with ax square plus bx plus c equals to 0, we get a equals to 1, b equals to 2 into m minus 1, c equals to m plus 5. Okay. So now for real and equal roots, b square minus 4ac equals to 0. Okay. So for real and equal roots, b square minus 4ac equals to 0. That is, b square means 2m minus 1 whole square. So 2 square, that means 4, m minus 1 whole square minus 4 into 1 into m plus 5 equals to 0. Now if we take common 4 and divide in the right hand side, the 4 is vanished. So I am writing here m minus 1 whole square minus m plus 5 equals to 0. So m square minus 2m plus 1 minus m minus 5 equals to 0. So that means m square minus 3m minus 4 equals to 0. So that means m square minus 4m plus m minus 4 equals to 0. That is m minus 4 and m minus 1 equals to 0. So either m minus 4 equals to 0 implies m equals to 4, or m minus 1 equals to 0 implies m equals to 1. So the value is m equals to 1 and 4. The value is m equals to, sorry, this is plus 1, so we get minus 1 here, so minus 1. So m equals to minus 1 and 4. This is the answer. M equals to minus 1 and 4. Note it down, all of you. Now, in number 8, see that find the values of P for which the quadratic equation this has equal roots. Also find these roots. So now see that equal roots is given, that means b square minus 4ac equals to 0. So 2p plus 1 x square minus 7p plus 2 into x plus 7p minus 3 equals to 0. So this is given. So 2p plus 1 into x square minus 7p plus 2 into x plus 7p minus 3 equals to 0. So now you have to write the comparing with ax square plus bx plus c equals to 0. We get a equals to 2p plus 1, b equals to minus 7p plus 2 and c equals to 7p minus 3. Okay. Now for equal roots, b square minus 4ac equals to 0. So that means 7p plus 2 whole square. So minus square means plus, so I am direct to write 7p plus 2 whole square minus 4 into 2p plus 1 7p minus 3 equals to 0. Okay. Now calculate it. So 49p square plus 28p plus 4 minus 56p square minus 4p plus 12 equals to 0. Okay. Now, so minus 7p square minus plus 24p plus 16 equals to 0. So that means 7p square minus 24p minus 16 equals to 0. Now, if we solve, then 16 into 7, 112. If you solve 112, then 20 into 4. So 7p square minus 28p plus 4p minus 16 equals to 0. So that means 7p plus 4 into p minus 4 equals to 0. So 7p plus 4 into p minus 4 equals to 0. So we can write here either p equals to minus 4 by 7 or p equals to 4. So the value of p is minus 4 by 7 and 4. Okay. Now you have to put this value in this equation and you have to solve. See that. For p equals to 4, we get 2 into 4 plus 1, that means 9x square, minus 2 into 7, 14, 14 plus 2, 16, so 16x plus 2 into 7, 14 minus this is 4 means 30, and this is 25 equals to 0. So 9x square minus 30x plus 25 equals to 0. Now solve it. So 25 into 9, this is 25. So 9x square minus 15x plus 25 equals to 0. So that means 3x common. So 3x minus 5, then minus 5, 3x minus 5 equals to 0. So that means 3x minus 5 equals to 0. So either 3x minus 5 equals to 0, that means x equals to 5 by 3, or 3x minus 5 by 5 equals to 0, that means x equals to 5 by 3. So if p equals to 4, then x equals to 5 by 3 each, that means equal roots. So x equals to 5 by 3 comma 5 by 3. This is for p equals to 4. Now we are calculating for p equals to minus 4 by 7. See that. For p equals to minus 4 by 7, we get minus 1 by 7 x square plus 2x minus 7 equals to 0. That implies x square minus 14x plus 49 equals to 0. That implies x square minus 7x plus 49 equals to 0. That means x into x minus 7 x minus 7 equals to 0. That means x minus 7 and x minus 7 equals to 0. So the value of x are 7. So either x minus 7 equals to 0 implies x equals to 7, or x minus 7 equals to 0, that implies x equals to 7. So both the values of x are 7 here. So x equals to 7 comma 7. Okay. So when we are taking p equals to 4, we get x equals to 5 by 3 comma 5 by 3, and when we are taking p equals to minus 4 by 7, we get both the values of x are 7. So we see that the values of x are equal roots here. Now next one. Now in number 9, see that 2x square plus 3x plus p equals to 0. So it is given, and in question given that find the values of p, which quadratic equation this has real roots. So real roots means greater than equals to 0. Same process. So comparing with the equation x square plus bx plus c, we get a equals to 2, b equals to 3, c equals to p. Okay. Now for real roots b square minus 4ac greater equals to 0. That means, put the value now. So 9 minus 8p greater than equals to 0. Now by linear inequation we can write here p is less than equals to 9 by 8. Okay, so p is less than equals to 9 by 8. Note it down all of you. In number 10, see that x square plus kx plus 4 equals to 0. Now, for comparing with ax square plus bx plus c, we get a equals to 1, b equals to k and c equals to 4. Okay. Now for real values, b square minus 4ac is greater than equals to 0. So that means k square minus 16 greater than equals to 0. So that means k square less than equals to 16. You can also write k less than equals to 4. Okay. So for k equals to 4, the least positive value of the k. So what is the least positive value of k? So least positive value of k is 4. Okay, so k equals to 4 is the least positive value. Okay, that's all for 5D. So rest of the work are homework. Submit your homework positively. Thank you all of you. Take care. Bye bye.